So here we will try to understand electric dipole and we will try to understand what is the electric field near a dipole. So before we proceed, I hope all of you have understood what an electric field is. So now we will try to put some effort in trying to understand what is a dipole. So dipole basically represents two equal and opposite charges separated by a small distance. So I have a positive charge here, a negative charge here, separated by a small distance d. So two equal and opposite charges separated by a distance d constitutes a dipole. So here we have a dipole. An electric dipole is given by its dipole moment, which is equal to the charge into the distance separating the two. Now here I have written the distance separating as d. In many books they write it as 2d. So if the distance separating is 2d, the electric dipole will be q into 2d. Now here I have written d, so it is simply equal to q into d. The dipole moment is represented by a vector quantity called p, and it is a vector quantity, and the direction of the vector will be from the negative charge towards the positive charge. Yeah, so I hope you get it. The direction of the electric dipole moment is from the negative charge towards the positive charge. Now what we are interested in is, suppose there is a dipole, here there is a plus charge and here there is a minus charge. At any point, so this you see, this is what this point here is known as the equatorial point. This point here is known as the axial point. If your dipole is placed this way, suppose this is the negative charge and this is the positive charge, this point here is called the axial point and this point here is called the equatorial point. So we are interested to know what is the electric field at the axial point and equatorial point. Once we find out what is the electric field at an axial point or equatorial point, even very tough questions at any point we will be able to answer, but that is not required as far as the NCERT is concerned or as far as the NEET exam is concerned. You will get simple questions where if you understand the basic concepts, it is all done. So the kind of questions that we will get is, what is the electric field at an axial point? What is the electric field at an equatorial point? So let us try to understand that and answer. So first I will find out the electric field at an equatorial point. So here is an electric dipole, this has a charge minus q, this has a charge q here, and these two are separated by a distance 2d. So that half of it is d, this half of it is d. The question given to me is, find the electric field at a point at a distance y on the axial, on the equatorial point. So this is an equatorial point, this distance from here to here is equal to y. Okay. Now already we have discussed the principle of superposition. Whenever there are multiple charges, net field is going to be equal to sum of individual fields. So here at this particular point P, the electric field will be equal to the electric field due to the positive charge and the electric field due to the negative charge. That means it will be E plus Q plus E minus Q. Now students understand that a negative charge is going to pull a positive charge towards itself. So this is going to be the electric field due to the negative charge, and the positive charge is going to push the test charge away. So this is going to be the direction of the field on the positive charge, and if you resolve this into components, this component here and this component will get cancelled. So we are left with a component along this direction. Okay. So now if this angle here is theta, this angle also will be theta. Why? Because this full thing is 90, this is already there, this plus this is also 90. So this angle here is 90. So if this angle there is 90, we are talking about E plus Q cos theta plus E minus Q cos theta. That means the electric field due to the negative charge cos theta plus the electric field due to the positive charge cos theta. Okay. So what is that? What is cos theta? Cos theta is going to be adjacent side divided by hypotenuse. So cos theta will be equal to d divided by square root of y squared plus d squared. I am applying Pythagoras theorem. So from here I can say that E plus Q is this much, E minus Q is this much, and both of them are in the same direction. So when you add, you will get this much. That means you will get 2 times k q d divided by d square plus y squared power 3 by 2. Okay. Now please understand that 2 times q into d will give you p. So this is kp divided by, now this d is very small. So if d is very small, this whole thing can be approximated to y squared power 3 by 2. So it will become y cubed. So that is the electric field. Now electric field is a vector quantity. So if electric field is a vector quantity, it should have a direction. Already we are telling that direction of the dipole is from the negative charge towards the positive. But here the electric field is in the opposite direction. Because the electric field is in the opposite direction, I will say the electric field is minus kp by y cube, where I put a vector sign here, so that once we know what is the direction of the electric dipole moment, we can find out the direction of the electric field at a equatorial point. Okay. So I hope you are able to understand this particular derivation. This derivation is important. It is a 3-mark question which comes quite often in your NCERT exam. Those of us who are preparing for the NEET exam, we do not really have to know this derivation, but if we understand the final result and if we remember the final result, it is more than enough. Okay. Next let us try to find out what is the electric field at an axial point. So here this is an axial point, this is the axis of the dipole and this is an axial point. Suppose this distance from here to here, let us say, is x, and this distance here is d. So again from here to here we will get x minus d, and the distance from here to here will become x plus d. So the electric field at any point will be equal to the electric field due to the positive charge plus the electric field due to the negative charge. This is what the principle of superposition says. So the electric field will simply be equal to kq by x minus d the whole squared plus kq by x plus d the whole squared. So I hope you are able to understand. But this is a positive charge, so at this point the field will be in this direction, but for the negative charge the field will be in this direction. So the plus here will not be correct, that has to be a negative sign. So if I perform this operation, I will get the answer. So let me take the LCM. So the LCM will become x square minus d the whole squared minus d squared the whole squared, and kq is common to both. So I will get x plus d the whole squared minus x minus d the whole square. Okay. So now when you simplify this, I can write this as x square plus d squared plus 2xd. I can write this as minus x square minus d squared plus 2xd. So all these will get cancelled. So you will finally get that the electric field at an axial point is equal to kq. So you have 2xd here, 2xd here. So 4 times d into x divided by x square minus d squared the whole square. Okay. Now the electric field is in which direction? It is in this direction, same as that of P. So the dipole moment for this will be q into 2d. Why q into 2d? Because this is d, this is another d. So the total distance separating the two charges is 2d. So the dipole moment will be q into 2d. So when I substitute here, I will get 2 times k p x. Similarly, if I take d to be very small, I will get x power 4, which if I rearrange and cancel, I will get 2 times kp by x cubed. Okay. So at the axial point, the electric field is equal to kp 2kp by x cubed. At the equatorial point, the electric field is minus kp by y cubed. Okay. So this is a very, very important output that you should remember. Very frequently they have asked 3-mark questions based on this, either the axial or the equatorial. So please make sure that you are pausing the video, watching this repeatedly till you understand it, until you are able to derive it. Also please understand how I am writing down the fact that according to principle of superposition, this is what is true. So I have approached it stepwise. So if you approach it stepwise, there is no way you will go wrong. Also the diagram is very important, so that the person who is correcting your paper knows that you understand the subject. Okay. So this is what I have for you. In case you are writing your board exams and you think you want some more papers on these areas, please reach out to us. We will be very happy to help you. Our number is 98948 99776. Similarly, if you are preparing for the NEET exam and you want some question papers related to this, we can help you. Please reach out to us. We will be very happy to have you. We do courses for repeater students, those who want to prepare for the NEET and JEE. We also have courses for the crash course, that is once your board exam is over, we have a very intensive program where daily you will have classes preparing you for the entrance exam, both the NEET and the JEE. So in case you are interested, please reach out. We will be very happy to work with you and help you achieve your dreams. Thank you.